Welcome to Oryx Learning. Today's lesson is on Unit 3, Equations in Two Variables, Lesson 3, Direct Variation Equations, y equals mx. How much do I weigh on Mars? The weight of an object on Mars varies directly with its weight on Earth. A person that weighs 25 kilograms on Mars weighs 100 kilograms on Earth. If a person weighs 120 kilograms on Earth, how much does that person weigh on Mars? If you'd like to know the answer to this question, please follow along and we'll come back and visit it at the end. Direct variation. A linear relationship is a direct variation when the ratio of y to x is a constant m. We say y varies directly with x. M equals y over x, or y equals mx, where m is the constant of variation and m cannot equal 0. Direct variation equations can look like y equals 3x, y equals 6x, or y equals 1/2 x. If the direct variation equation is y equals mx, the graph of a direct variation function is always a linear function passing through the origin. The y-intercept of a direct variation function is always 0, 0. So as shown on the graph here, we have a direct variation graph. That's a linear function that goes to the point 0, 0. Here's a linear function with a negative rate of change that goes to the point 0, 0. And a third example showing all three with a y-intercept of 0. Which of the following is a direct variation equation? Well, if we think of the graphs, we know that it has to be a linear relationship and it has to have a y-intercept of 0. So if I were to graph the first graph, y equals negative x plus 5, I know that the y-intercept, the b value, is 5, and the slope is negative 1. So this graph has a y-intercept of 5, which is not 0, so it cannot be a direct variation. Same for the second graph, 3x plus 7y equals 2. That graph also does not have a y-intercept of 0. The third option, 2y equals negative 6, is just a horizontal line, and the horizontal line does not pass through the origin, or 0, 0. The fourth option, y equals 2x, passes through the origin, 0, 0, and it's a linear function with a slope of 2. So our correct answer is going to be the last option, y equals 2x. Is the function represented in the table a direct variation? So if we look at the table, we have time in hours and distance in kilometers. If we use the formula m equals y over x, we get 12 over 3 for the first point, 12 divided by 3, y divided by x, 15 divided by 5, 21 divided by 7, and 27 over 9. Now, since the first two do not have the same values, they cannot be a direct variation because direct variation has that constant of variation, that m value, where all the y over x's should be the same. 4 does not equal 3, therefore this is not a direct variation. The amount of money that Jill earns working in a bakery is directly proportional to the hours she works and is shown in the table below. Graph the data, then find out how much Jill earns per hour. So in order to graph the points, we can use our coordinates to graph 4, 22, so over 4 up 22, 5, 2750, and 6, 33. Graphing these points, it looks like a linear function that goes to the origin, therefore a direct variation equation. In order to find out how much Jill earns, we can find the constant of variation, which is m equals y over x. And if we take our y over x for the first point, that's 22 over 4, which is 550 per hour. The number of sales y per hour x on Jane's website can be represented by y equals 12x. The number of sales on Sarah's website is shown in the graph below. Whose website gets more sales per day? Sarah's website gets 10 sales per day, right? And we can see that on day 3, she had 30 sales. On day 4, she had 40 sales. And on day 5, she had 50 sales. So the constant of variation is 10. 10 sales per day. Jane's website, as shown in the equation, gets 12 sales per day, as that is her M value. Therefore, Jane's website gets more sales per day, as 12 is greater than 10. A delivery driver makes 24 deliveries in 4 hours. Assume that the number of deliveries is directly proportional to the number of hours. Write the direct variation equation, then find how many deliveries he can make in 7 hours. So if we take our constant of variation, deliveries per hour, says he can make 24 deliveries in 4 hours. That makes our constant of variation 6 deliveries per hour. Substituting that into our equation, y equals mx, we get y equals 6x. If I want to find how many deliveries he can make in 7 hours, I will substitute in a 7 for the x value, which leaves me with y equals 6 times 7, or 42 deliveries in the 7 hours. Let's go back to our Mars question. How much do I weigh on Mars? So again, the weight of an object on Mars varies directly with its weight on Earth. A person that weighs 25 kilograms on Mars weighs 100 kilograms on Earth. If a person weighs 120 kilograms on Earth, how much does that person weigh on Mars? So if I let x represent the weight of a person on Earth and y represent the weight of a person on Mars, then m equals y over x would give me 25 over 100, which reduces to 1 over 4. So my constant of variation is 1 over 4. Substituting that into my equation y equals mx, I get y equals 1 over 4x. And substituting in 120 for my x value will give me y equals 1/4 of 120, and 120 divided by 4 is 30. Therefore, a person that weighs 120 kilograms on Earth would weigh 30 kilograms on Mars. So to review, a linear relationship is a direct variation when the ratio of y to x is a constant, m. We say that y varies directly with x. Our equations are m equals y over x or y equals mx, where m is the constant of variation and m cannot equal 0. Remember that direct variation equations always have a y-intercept of 0. Each of the graphs will pass through the origin or the point 0, 0. That is our lesson for today. I hope you enjoyed it.